All right, well, good evening, everyone, and welcome to this special webinar hosted by the Oregon Kelp Alliance. I'm Tom Calvanese, manager of the OSU Port Orford Field Station and director of ORKA. Thank you for joining us for the release of the 2024 Oregon Kelp Forest Status Report, a milestone achievement in understanding and protecting our state's vital kelp forest ecosystems. Before we begin, I want to express our gratitude to Senators Jeff Merkley and Ron Wyden and former Representative Peter DeFazio. Their unwavering support and success in securing federal funding was instrumental in making this comprehensive effort possible. We're profoundly grateful to the numerous scientists, researchers, partners, community scientists, and stakeholders who contributed their expertise and data to this report. Tonight, we have an outstanding group of experts joining us. Dr. Sara Hamilton, our ORKA Science Coordinator, will present the key findings from the report. Following her presentation, she'll be joined by our distinguished panel of experts during a Q&A session. These include Dr. Sarah Gravem, Research Associate in the Department of Integrative Biology at Oregon State University, Dr. Erin Galloway, Associate Professor at the University of Oregon's Institute of Marine Biology, Diana Hollingshead, Regional Manager for Oregon Reef Check, and Jim Burke, Head of Scientific Diving Program at the Oregon Coast Aquarium. The Q&A session will be moderated by Carl Hendrickson, ORKA's Administrative and Program Assistant, with support from Caroline Rice, Operations Assistant at the Port Orford Field Station. Please use the Q&A function to submit your questions throughout the presentation. For those who may need to leave early or wish to review the content later, this webinar is being recorded and will be made available on our YouTube channel. If you would like to view the report after this webinar, it will be available on our website at oregonkelp.com. And while you're there, please join our mailing list. We will be scheduling community events along the coast in the coming weeks and months to focus on the status of your kelp forests, your local kelp forests. So please join the mailing list and follow us on social media at Oregon Kelp. And with that, I'll turn things over to Dr. Sara Hamilton to share some key findings of this groundbreaking report. Dr. Hamilton.
Okay, I think everybody can see my screen. Thanks for that introduction, Tom, much appreciated. And I'm really excited to share what we found with everybody. Thanks for being here today. I'm going to move a little quickly through this material because we want to keep this keep lots of time for questions and answers. But as mentioned, you can always go access the report itself to really dig in deeply to the details. So I want to also emphasize, as Tom did, that this was a really big team effort working with people from across the state. So we had, I'm presenting today, but I had 7 co-authors: Tom, Sara Gravem, Erin Galloway, Delaney Chabot, Emily Vidusik, and Natalie Webster, as well as literally dozens of contributors and collaborators across a whole set of different institutions that helped us make this the best product that we could make it. So I want to acknowledge and thank all those people from all these different parts of the state that helped make this happen. So how did we create this report? We had 2 goals that we wanted to do with this report. And the first one was to assess what are the current conditions of Oregon's kelp forests. And then the second one was to compare the current conditions to past conditions, because you got to kind of know where you came from to understand exactly where it is you are now and where you're going in the future. And so starting with that second goal, we worked with Oregon Department of Fish and Wildlife and Reef Check to access historical and ongoing time series of kelp forest relevant metrics, kelp forest relevant species. And then in 2023, we had this really big effort that included over 170 scuba surveys, as well as 21 drone surveys that took place from Brookings all the way in the south, all the way up through Cape Lookout in the north, as we wanted this to cover as much of the state's kelp forest habitat as possible. So that kind of begs the question, where exactly are Oregon's kelp forests? So what you see here over on the left are maps of bull kelp forests in the state using satellite data. And so why can I use satellite data for this? Well, bull kelp is one of our key species of kelp here in Oregon, and it is a canopy forming species. So just like forests on land, you have the big Doug firs that are the tallest ones around, and they create a canopy. Bull kelp grow all the way to the surface. And so you can look down on the kelp forest from a plane, a satellite, a drone, and see what the extent of the bull kelp is, which makes it really handy for mapping out where are our kelp forests. So starting from the north and going south, kind of the northernmost major outpost for kelp forests in Oregon is Pacific City around the Chief Kawanda Rock and Cape Lookout. And these numbers that you see, these numbers that you see indicate about how much of Oregon's total kelp forest area was present in that specific region prior to 2010. So Pacific City was pretty small, about 1% of total kelp forest area. Moving south, you get to Cape Foulweather, which is just north of Newport, just south of Depot. That had about 5% of Oregon's kelp forests historically. You go way far down, skip over all the sandy stretches around Florence, and you get to Cape Arago, which historically had about 5%. And then you get to Cape Blanco, which includes Blanco Reef and Orford Reef. And this is a really, really important part of our kelp forest ecosystem because historically it made up about half of our total bull kelp forest area in Oregon. Moving south, you have Redfish Rocks, which is right off of Port Orford with about 13%. Rogue Reef at the base of the Rogue River at Gold Beach with about 12%. The Samuel Boardman Corridor moving south with about 6% of our historical area, and then further south down Brookings about 4%. So you can see that a good chunk of our bull kelp forest historically was really located on the south coast, although we do have some of those important outposts further north. So let's just jump right into it and kind of start with that second question of how has bull kelp changed over time? So because we can use satellites and plane surveys and things to map out kelp forests, we were able to use historic aerial surveys that were conducted by Oregon Department of Fish and Wildlife, as well as satellite data to assess how the size of these bull kelp forests changed from 2010 to 2022. And we chose those years, 2010 and 2022, because those were when the most recent ODF&W aerial surveys have been conducted. And so again, starting in the north and moving south, Cape Lookout from 2010 to 2022. In 2022, it had about 92% less kelp than it did in 2010. Cape Foulweather had about 44% less kelp. Cape Arago, 23% more kelp, so a little bit of a gain there. Cape Blanco, about a 95% loss. Redfish Rocks, 26% loss. Rogue Reef held essentially steady with just a 1% gain. And Brookings had about a 74% loss. So overall, when you kind of add up the total bull kelp area across the whole state, in 2022 versus 2010, we had about 67 to 73% less bull kelp in the state than we did a decade and a half ago. And so that's about a loss of about 900 acres of habitat. And additionally, it's really important to note that these losses are not spread evenly across the coast. Some places you get near total loss, like Cape Blanco, and then some places actually have shown a small gain over that time period, like Cape Arago. So the planes and the satellites are great for doing these big scale mapping, but to really understand a kelp forest, you have to go beneath the surface to assess the whole community. The community includes lots of different kinds of kelp in addition to bull kelp, so things like old growth kelp and torn kelp, as well as grazers like purple and red sea urchins. And so going beneath the surface here, we have an example from a reef check time series based on scuba surveys from Macklin Cove, which used to be, and still is, a popular shore diving spot down by Brookings. What you see on the left graph here is a time series from reef check surveys at Macklin Cove of how much kelp there was. So starting in about 2017, you can see on the y-axis that on average, a reef check survey found about 2.5 kelps per square meter. And when you think about per square meter, the best area I could come up with was like a big doormat or a big welcome mat. So 2.5 kelps per welcome mat size in 2017. By 2019, the next time there were surveys there, it had dropped significantly down to about 0.5 kelps per square meter. And then all the years after that we have data, 2020, 22, 2023, no kelps were found at those exact same sites that Reef Check was going back to survey. Conversely, over here on this right graph, you see that at that same site over that same time period, what was the density, what was the abundance of these two urchin species, purple urchins and red urchins? And completely opposite of kelp, back in 2017, when Reef Check first started doing their surveys there were very few urchins. Only 1 or 2 surveys found any purple or red urchins at all. And looking particularly at purple urchins, by 2019, those numbers were going up. And then the last few years, their numbers have kind of bounced around something like 5 urchins per meter square. So purple urchins have really increased over that time period, and red urchins at this site increased maybe a little bit. And so what you see is, as purple urchin densities increased at this site, we got a huge decrease in the amount of kelp, essentially to the point where there is no kelp there anymore. And as we were doing the analyses for the status report, we have this really high quality data from Macklin, but we found that Macklin Cove wasn't the only place that experienced these big increases in purple urchin populations. In fact, most sites where we had the data to assess change in purple urchin density over time, we found significant increases in purple urchin density. Sometimes these were mild, but at least one site, we found 1,000-fold increase in the density of purple urchins. So you can see some pictures over here on the right of what that kind of looks like when you're down diving these sites. In some places, purple urchins kind of carpet the bottom. There's very little, if any, kelp, and when you do come across kelp, there can be urchins climbing up the stipe, kind of grazing it down. So along with this loss of kelp over time, increase in urchins, we also found that across the same time period, sea star wasting disease really knocked out one of the last major urchin predators left in Oregon, which was the sunflower sea star. You can actually see a picture over here on the left of a juvenile sunflower sea star in the process of eating a little tiny purple urchin and spitting its skeleton, its test back out. So at Otter Rock and Redfish Rocks over the same time period, you can see in this time series that sunflower sea stars went from being a pretty common sight on dives here in Oregon to nobody saw them for years and years and years at a time. So I'm moving quickly. Those slides were about how things have kind of changed over time. Like I said, you got to know where you came from to know where you're going. And now we're going to dive into what it was we found in these 170 scuba surveys that we did in 2023. So there's a lot of maps going on here. So let's break it down. What you see here are the 6 of these major kelp forest areas: Foulweather, Arago, Blanco, Redfish Rocks, Rogue Reef, and Brookings. Each one of those has a little map inset, and every dot on this set of maps over here to the left represents a scuba survey, and the color of the dot represents what was the abundance of kelp at that site. And so you can see the darker dots, like some of these ones around Cape Arago, had high densities of kelp. Lighter dots had lower densities. And then these places where you see the black ring with nothing filled in, that means there was no kelp on that survey. So you've got the set of scuba surveys, the kelp density over here on the left, and then the furthest right set of maps are those exact same sites and what was the abundance of purple urchins at those sites with the same thing. Dark colors equal more urchins, light colors less urchins, black ring with nothing in it equals 0 urchins. So like I said, there's a lot going on here, but one of the first things to notice is that there's a lot of variability. Things can change a lot in a small space. Some places consistently had basically no kelp, while other areas had dozens of kelp per square meter, per doormat. And same thing with purple urchins. So we have a patchwork of kelp forest conditions across the state, and things vary a lot, not just from reef to reef, but even within the same reef. However, when you spend a bunch of time looking at all these different maps, like I did, even through all this variability, you begin to pick out areas that really consistently had low numbers of kelp and high abundances of purple urchins. In particular, I kind of want to point out the Redfish Rocks area and the Brookings area. In the dozens and dozens of surveys that we did in those areas, we only found a couple of sites that had any kelp whatsoever, which was certainly disheartening. But conversely, we found areas where divers were consistently found kelp, and sometimes really high densities of kelp, along with generally the areas with more kelp had lower urchins. So you can see that Cape Foulweather, parts of Cape Arago, Blanco Reef, and then Rogue Reef were some of these areas that did support substantial kelp populations still. And I don't really have time to get into the drone findings today, but I just want to let you know that the drone surveys we did found similar patterns in where there was and wasn't kelp to be found. So there's kind of a lot of information going on here. And what we wanted to do was create a simple index that helped us understand different levels of concern for our kelp forests across the state. And so we created an index that was based on how much kelp cover had changed since 2010, what the current densities of kelp were at those sites, and what the current densities of purple urchins were. And so we identified 3 areas that were of less concern. So no, I didn't say low concern and I didn't say no concern. I just said less concern. And these were areas that lost less than 40% of kelp from 2010 to 2022. Divers regularly found kelp in our 2023 surveys and found lower densities of purple urchins. And those areas were Cape Foulweather, Cape Arago, and Rogue Reef. Conversely, we have these higher concern areas. These were areas that lost more than 40% of kelp from 2010 to 2022. Divers in 2023 found very little, if any, kelp in these areas, and generally found very high densities of purple urchins. And those areas included Cape Lookout in the north, Cape Blanco, Redfish Rocks, and Brookings. And then I'll just note that the Boardman corridor down here in gray is pretty data limited. It's pretty remote. There's not a lot of ports nearby, and so we weren't able to do surveys there. So we're considering it data limited right now. But just to give you a sense of scale, when you total up the total area of these high concern areas, it's about 2/3 of Oregon's historic kelp forest habitat is classified now as high concern. So there's been a dramatic shift in the last decade and a half in our kelp forest habitat here in Oregon. And why has this happened? And why has it happened so quickly? Well, we know that there have been big increases in purple sea urchins, and we know that purple sea urchins, their favorite food is kelp. They can graze it down really quickly. So we know that that's a key part of the problem. Historically, here in Oregon, we had 2 major urchin predators. We had sea otters and sunflower sea stars. And as many of you may know, sea otters were extirpated by the fur trade back in the late 1800s, early 1900s in Oregon. And sunflower sea stars were lost to sea star wasting in about 2014, 2015. And so without those urchin predators around, not only did we see increases in purple urchins over time, if you look over here on the right, every single one of these dots on this graph represents a survey we did in 2023. The x-axis is what was the density of purple urchins. So over here on the left, you have very low to no purple urchins. On the right, very high. And then on the y-axis, corresponding at that site was their low or high kelp density. And what you can see here is that if you wanted to get these high numbers for kelp density, if you want a lot of kelp, you had to be on the lower half of the purple urchin density side of things. So the less purple urchins you had, the more likely you were to find kelp, and vice versa. As you found more and more purple urchins, that site was less likely to have kelp. And I just want to quickly note that this situation is not unique to Oregon. After the loss of sunflower sea stars happened kind of across large chunks of the North American West Coast, parts of British Columbia, Northern California, the Channel Islands, and Southern California all began documenting a similar increase in urchins and a decrease in kelp. So I'm talking about kind of the food web and how the food web is implicated in this dramatic shift, but we also are pretty certain that ocean warming and climate change are playing a part in this story as well. So for instance, we know that globally there is a really strong pattern that when the ocean warms, kelp forests decline or disappear because kelps really need and love cool water. So warm places with warming waters in Australia, Europe, North America, South America, globally, warmer water, less kelp. However, when we started kind of looking into nearshore water temperatures in Oregon, we kind of started looking at Port Orford, and we found that since 1993, water temperatures in Port Orford have only reached a stressfully warm level for bull kelp about 0.2% of the time. So it's really only been a couple of dozen days that there's been potentially stressfully warm temperatures for bull kelp. So we haven't dug into this fully, but at first glance, we don't see obvious evidence that the water temperatures here are too warm to support thriving bull kelp populations, at least in Port Orford. But there's a lot of research that needs to be done, a lot more digging we need to do before we can fully understand what the role of environment and climate change is in this story. So I've been throwing a lot of sobering numbers at you, right? 2/3 classified as high concern, 900 acres less of kelp. But one of the really exciting things for me in our 2023 surveys is that we also found some incredible signs of life and vitality in Oregon's kelp forests. And one of the examples I want to talk about for a moment is Cape Foul weather. So Cape Foul weather, just north of Newport, just south of Depot Bay. I did drone surveys there in 2023. And you can see over here on the left, this is a drone survey I did of the Otter Crust area. And you can see all that brown in there is this big, beautiful kelp forest that was stretching over about a mile. So really dense, happy kelp there at Otter Crest. And that was not the only place in Cape Foul weather I found big, happy kelp forests. I went up to Depot Bay, I went north of this site, south of this site, and I found all of these really big, dense patches of kelp. And that's really exciting, but what was even more exciting is over here, what I've done is I've taken the kelp from this drone survey of Otter Crest, and it's colored in pink. So that's where all that kelp was, kind of current conditions. And then if you look at this green outline, this is data I rummaged up from an old 1990 survey of kelp canopy from ODF&W, and it outlines what was the extent of the kelp patch back in 1990. And while they don't overlay perfectly, you can see that the area covered in pink is probably about as much area as the area outlined in green. And so from what we can tell from anecdotal reports of people who live there, from ODF and old ODF&W data, satellite data, it seems like in the Cape Foul weather area, 2023 was actually a historically good year for bull kelp. We don't know why exactly, but that was really exciting to see. And then another sign of resilience was that in 2023, as we started doing these surveys, we started documenting, along with community members, the beginnings of the return of sunflower sea stars. And so this graph here represents community member observations of sunflower sea stars in Oregon from iNaturalist.org and seastarwasting.org, which are websites where community members can post pictures of animals they're seeing, animals and plants they're seeing in their community. And you can see that in 2015, 16, 17, 18, nobody across the whole state noted that they saw a sunflower sea star. By 2019, there was maybe one a year, couple a year, very rare. And then in 2023, all of a sudden, we started getting people calling us from up and down the coast saying, oh my gosh, I didn't just find one sea star, I found 10 of them. And on iNaturalist and seastarwasting.org, there were more than 50 unique observations of sunflower sea stars, which was a huge increase kind of out of nowhere. And I think one of the really cool things about this is that community observations have been really critical in the work to document this potential recovery of sunflower sea stars. There are only a few scientists in the state actively documenting these things, but there are thousands of people doing their own dives or tide pooling that have been making observations and helping us keep an eye out for, a lot of times these are small sunflower sea stars, juvenile ones. And so one thing to note is that if you see something, say something. If you see a little sunflower sea star, please email us or record it on iNaturalist or seastarwasting.org. And this is particularly important if you're finding sea stars that are a little bit bigger, so maybe more than like 4 or 5 inches in diameter. If you see any of those, email me, text me, call any one of us. We want to know about it. So community observations are an important part of us documenting what could be the return of sunflower sea stars in Oregon. So that was also a really exciting thing that we got to see in 2023. So I know I'm going through a lot here. I want to leave time for questions. In summary, what did we find in our status report? We estimated that a loss of about 2/3 of Oregon's kelp forest habitat since 2010. A lot of that loss is concentrated on the south coast, particularly in Brookings and Port Orford area. We found high populations of purple sea urchins are a key cause of this kelp forest loss. And we did find places with dense, beautiful kelp forests still thriving here in Oregon. So not only have we lost a lot of habitat in a short period of time, we also still have kelp forests in Oregon that we need to start working now to make sure that we don't lose them. And to me, this situation is really urgent because we're already seeing the negative impacts of kelp forest loss on coastal communities and ecosystems. And so to kind of go through these pictures, researchers at Oregon State have found that gray whales who like to forage in and around kelp forest because that's where their prey likes to hide, gray whales have started changing their foraging patterns and where they're able to access food with the loss of kelp forests. In the middle here, red urchin fishery has historically been the third largest fishery here in third largest shellfish fishery here in Oregon. And red urchin divers are having a hard time finding high quality red urchins. They're having to change where they go, spend more time trying to find urchins. So this is really severely disrupting that fishery. And finally, over here on the right, one of the causes nearest to my heart, this is an abalone. An abalone are these incredible marine snails whose favorite food is kelp. They graze almost entirely on kelp. They have these beautiful pearly shells. I'm wearing my abalone earrings tonight, and they're culturally important for tribes up and down the US West Coast. And because their favorite food is kelp, we are seeing declines in all 3 species of abalone here in Oregon. And a recent paper co-authored by Scott Groth at ODF&W found that flat abalone, one of our species here in Oregon, are at risk of extinction in the next 15 to 20 years because their populations have gotten so low. So with that urgency, I want to just give you a brief look to the future and let you know that in 2025 and 2026, ORKA has received a new grant from NOAA that's going to fund restoration and protection work. And the 3 kind of pillars we're going to be coordinating within ORKA and with community members are going to be grazer control, so harvesting and culling purple urchins from sites of interest, kelp seeding, outplanting farmed kelp to restoration sites so that kelp can reestablish there once you've gotten the urchins out of the way, and then sunflower sea star recovery, promoting the recovery of sea stars both at kelp forest restoration sites and statewide. So I'll wrap up there to make sure that we have lots of time to kind of dig into people's questions, comments, concerns. But I just want to thank you so much for your time. I want to thank you for being here and caring about these ecosystems. As mentioned, if you want to read the full report, you can just go to www.oregonkelp.com, and there's a link right up there at the top where you can access the full report. So with that, I will go ahead and stop screen sharing, and we can dig into people's questions.
Nice job, Sarah. Well done. I see there's a hand out there, and I'm going to allow Dennis to ask this first question here, although I will also send folks to the Q&A. Dennis, go for it.
Hi, Sarah. Thank you for looking so extensively at our favorite area, Cape Foulweather. I had a question about slide number 14. Could you explain what's going on there? Because I'm just looking at the Cape Foulweather. I mean, this is the one that showed that lower, in general, lower sea urchin was correlated with higher kelp. But if I look at the Foulweather dots on that, you've got some dots all the way down to almost no urchins, and no kelp. So I was wondering what was going on in that chart.
Yeah, I'm gonna share the screen real quickly in case not everyone took as diligent notes as Dennis did. So this is the graph that Dennis is kind of talking about, and you're totally right, that, you know, there's a lot of there's a lot of variability in this relationship between site to site. So when you kind of zoom out and you look at it on an Oregon scale, there's this clear relationship, more urchins, less kelp. But when you zoom into individual sites, things can get complicated really quickly. So for instance, we've found some places, I've been on surveys at Cape Arago that have lots and lots of beautiful happy kelp as alongside pretty high densities of purple urchins. So Dennis is totally right. He's noting here that those kind of yellowish dots for the Cape Foulweather area, most of them are in pretty low purple urchin density zone. A lot of them actually found no purple urchins on these surveys. I'm going to ask Jim to speak a little bit more to this in a second here. I'll be entirely honest, we don't know why purple urchins bloomed in Orford, Port Orford area, Brookings area, some parts of Cape Arago, but it doesn't really seem like we've seen this super dramatic increase at Cape Foulweather. Now, I think that's probably contributing to why there was such a strong year for kelp in 2023 at Foulweather. There weren't urchins around to get in the way, but I don't know why exactly Cape Foulweather's been kind of spared. And I want to, Jim does a lot of work in that Foulweather and Otter Rock area. And Jim, do you have any thoughts or insights?
Sure, I could add a little bit. I don't have the answer, Dennis, but all those sites that we dive up there are based on the Oregon Marine Reserve and the Cape Foulweather, the Otter Rock Marine Reserve and the Cape Foulweather comparison area. And those are select sites that have been surveyed for over 10 years now. And we're not specifically going into the kelp areas, although some of those areas are full of kelp. My observations there for the last many years is it's a fairly healthy balance of kelp and urchins. But like anything, it's a cycle and these things can change. But maybe the answer there is some of these sites are either shallower where different kelps are, or deeper or off a little bit. But I think some of that could be site selection and trying to be non-biased while we're looking at the marine reserves. Does that help, Dennis, or do you have any follow-up?
I'll allow Dennis to talk again. Dennis, are you feeling satisfied with that?
Sorry about that. Yeah. I was also questioning, that the foul-weather dots are all on the low side of sea urchin. So I'm wondering why some of the ones that are very low don't kind of verge over to the higher rates of kelp.
Yeah, that's a good observation, and it's an interesting question. And some of the things we saw in the large recruitment of juvenile urchins several years ago as an echo of the sea star wasting, we saw a lot of urchins south of Newport where we hadn't really seen them historically, especially a lot of recruits, and we were not seeing recruits at that level up at Otter Rock, Cape Foulweather area. And I don't necessarily have an answer for that, but some type of oceanographic condition, currents might have helped spare that zone a little bit during that mass recruitment that we had in 2018 or so, 2017, 2018. That could be part of that. But we did not see the little tiny guys that showed up everywhere, including, from South Reef down to through the Seal Rock area, where we typically would not see urchins in the past, or not many. And most of what exists in the foul-weather area have been somewhat what I would consider balanced and healthy. So it's an interesting observation. It's a little anecdotal, but some of the data shows that, and I think that's just a good reason to continue doing these annual surveys, biannual surveys.
And I want to just add one thing on to Jim's comments, which is that historically there hasn't been a lot of science and research into kelp forest ecosystems in Oregon. That's something California's had for decades, parts of British Columbia and Washington. And so I just want to, there's a lot we don't know and a lot of basic fundamental research that still remains to be done. So we did a lot in 2023. But there will be so many questions we can't answer because there hasn't been a lot of work prior to 2023. Yeah.
I have a quick ecological insight to add for Dennis's question, if we have time. So Dennis, the prevailing thought on echinoderm recruitment is that it's very sporadic. So like it's very much a like boom and bust sort of situation. And so it might literally be luck that like some sites escaped the recruitment and some sites did not. And then the other possibility is that at least some of the intertidal work we do shows that Cape foul weather has generally lower recruitment of all sorts of things, barnacles, mussels, etc., compared to some of the more some of the other capes. And so it might be an oceanographically based pattern that has to do with like shelf width and the speed of the currents and upwelling winds and things like that. So that I can't say that that's the reason, but it isn't out of the realm of possibility that Cape foul weather just has generally low recruitment of stuff, at least like with pelagic larval phases, and that might have helped spare it.
Interesting. Yeah.
We'll see.
Awesome. Well, I want to get to some of the questions we're getting through the Q&A too. So I'm going to switch gears to the first one up there, which gets into the last sea otter sighting we had in Oregon. And there was one somewhat recently, if a panelist wants to jump on that.
Yeah, Jim, you might be more aware with the sea otter program at the aquarium.
Sure. There's been several this year. There were more last year. Most have been found DOA on the beach with shark bites. We brought one in a few years ago in November, late November, early December, and did emergency surgery on it. We were not able to recover that animal, unfortunately. But the Oregon State University Marine Mammal Stranding Network post, you should be able to find a link there to see all the strandings of all marine mammals, including sea otters. When we've had them, we've done genetic work on them, and they've all been from the Washington population. So we think they're young males coming down. We did see 2 young males off Cannon Beach. That might be the one you're referring to, and that was probably 2 or 3 months ago. We had some eyes on them. There were some pictures, but the animals are coming down. It's always males coming to find new habitat as the population up off of the Olympic Peninsula gets more robust. It'd be wonderful if they were able to come down naturally, and maybe they will. I just think it might take a long time.
Awesome. Thanks for that, Jim.
Yeah, you're welcome.
We're going to change directions here from another online chat. From Tyson Rasser, do we really need to use farm-raised kelp / seed kelp for restoration? Once we get the urchin problem out of the way or reduce their populations, won't they naturally reestablish?
Yeah, this one, Tom, do you want to chime in on this one?
Sure, I'll tag team it with you, Sarah, since we just had a discussion about this. So I think it's the answer is maybe. And one thing we know from what we see in Northern California, where there have been huge areas where there's been kelp loss, is that it's really difficult for the kelp to reestablish because it's an annual and needs to basically reestablish itself every year. And it can only do that from existing kelp that's producing spores. that can trigger that reestablishing. So we're launching a restorative kelp mariculture project as well. And one of the things we're looking at, in addition to removing urchins, is doing work to increase the spore density in those areas where we have reduced urchins or remove them, because it's sort of a 1-2 process where we have to remove the grazers, but also enhance the capacity of that area to reestablish kelp by having the early life stages of the kelp present. And if there's no kelp, there's probably no early life stages of kelp present. That's my quick answer. But Sarah, if you want to expand on that, please do.
Yeah, I think one piece of this that's really interesting for me is that once a kelp forest has reestablished, it's got some resilience to urchin overgrazing. So when there is a full kelp forest there, urchins don't actually want to be out and about grazing down things. They actually want to hide in cracks and crevices in case there are predators around, and just wait for drift kelp to come by them, and they can snag it and just have a little snack without having to go anywhere. And without any kelp around, that's when they have to come out of these cracks and crevices and go wandering around and grazing down any kelp that they can find. So essentially, we want to help. You're totally right. Kelp, if we get enough urchins out of there, kelp may recruit back. We don't know how long that would take. So this is really about accelerating how quickly kelp can reestablish there, because once it's reestablished, even if there are high densities of urchins, we're going to have less of an overgrazing problem, because there's going to be lots of drift kelp, that the kelp sloughs off, that falls to the floor and the urchins eat it up. So I think it's also about a timescale question. Like, let's go ahead and get these kelp back where they belong and reestablish this balance.
Can I add to it? Yeah, I think it's a great question. I find that it gets to the heart of a lot of the issue here, which is what we're talking about. Kelp forest declines at this scale are not, there's no satisfying, easy way to help recover that. That's the truth of the matter. And so we're grasping at which levers can we possibly pull. I like to use the levers analogy. And any given lever on its own is not going to be satisfying. So one of the ones that you mentioned, like, why can't we just wait for the urchin situation or do something about the urchins? That's almost that's a difficult one. We're doing the best we can, but the scale of the coast and the scale of at which we can do anything about the urchins is so little that again, even the spore seeding is also a scale issue. But basically what we're looking at is how many different levers can we possibly pull, and can we measure the outcomes when we pull those, to try to do something. Partly not just from a scientific perspective, but because it's valuable to our community. We hear that the community wants to do something and wants to help recover kelp forests, and that's just one of the ways that we can. So including possibly this kind of predator enhancement, but all those things on their own are not going to be satisfying. I kind of agree with you, and unfortunately, that's the situation we're in. We're just trying to do the best we can.
Thanks for all that explanation. Yeah, it's certainly not going to be solved immediately, but with this team, I think we're looking all right. I have a sort of two questions I'm going to combine together. One is noting that Oregon has lots of ecological historical kelp on it, but still has good invert and other algae populations. So noting that there's sort of that other habitat out there. And then a comment from someone with the Oregon Coastal Management Program looking at site management for the rocky habitat protected areas with local communities, and wondering if there's any community science efforts at Cape Lookout, Cape Foulweather, or Cape Blanco, and how that could help out ORKA's efforts at those particular sites. So any community science? I'm looking at you perhaps, Diana.
Yeah, I can take a stab at that. So what Reef Check is doing is we are involving the community in doing benthic surveys underwater. And so we have done several surveys at Cape Lookout, not at Cape Foulweather, but are hoping to expand into Blanco next year, 2025. We have seven sites already around in the Port Orford area, but hoping to make Blanco Reef at least 2 sites there next year also. And we're always looking for more community members to join the team, and you can contact me directly for how to get involved with that.
Yeah, I think so. Diana does such an awesome job managing some of our diver-based work. I think I think Gravem actually would be a good person to whose brain to pick on this. You know, there's so many people that can't dive or don't want to dive, and thinking about how in the intertidal we could do science that supports, helps us understand what's going on at these kelp forests. There could be things around water temperature monitoring, purple urchin recruitment. I know we've seen a big recruitment boom in purple urchins in Nellie's Cove this year, and that may show up in the intertidal as well. So those are 2 that I can think of off the top of my head. But also, I think that sounds like a follow-up call that we could all get together and think about how do we partner on that. So thanks for bringing that up.
Okay, Carl hopped off, so this is Caroline stepping in. We're going to take a question from Faith Orton. She asked, what are the causes for the huge increase in purple sea urchins? Is the water temperature a significant factor? And she said it didn't sound like it was based on the lack of temperature stress on the kelp, but maybe what are some of those other recruitment dynamics for the purple sea urchin?
I can start, and then maybe anybody else can jump in if my answer's incomplete. We don't know. So there's this kind of black box in marine biology of larval biology, because a lot of marine critters have this larval stage that is teeny tiny, and it's really hard to figure out where they are and how they're doing. And you can't tag something that's microscopic and follow where it goes and how it responds to different environmental conditions. So understanding marine larval recruitment pulses is, there's a lot of unknowns there. I think some of the current theories are, one, that without sunflower sea stars and other big sea stars around to munch down the little urchins, maybe there were recruitment pulses that were happening in the past, but they were being grazed down, they were being predated on by other predators in the system. So that's one hypothesis. And then there's a whole host of environmental conditions that could be related to it. So it could be that purple urchin larvae do well when the water's a little bit warmer. And so whenever we have these marine heat wave events, the purple urchin larvae survive and can really take over an area. Could be temperature. It could be something to do with acidity or hypoxia or salinity. So I think, and Graham and Galloway can correct me on this, I think people have been kind of looking at this along a lot of the West Coast, and still there's not a whole lot of good understanding of the urchin recruitment processes. So in my mind, it's kind of an open question, not just here for us in Oregon, but elsewhere as well. So, but others are free to weigh in.
Sarah, I'll take just a little comment, just to maybe try to simplify it, or one aspect of it. Look at it as an echo effect of sea star wasting. There's more to it than that, but with the sea star die off and the little urchins aren't getting munched, and I mean, I think that's a big part of it. It is more dynamic than that, understood, but there's a lot of echo effect from what we saw in 2013, 2014.
And just so y'all know, we're going to try and work on that soon. So Jim has babies in his tanks at the aquarium, and we're feeding them baby pick nose, and we're feeding them baby urchins right now to try and understand how all that interacts and how well we think they would be, how good they might be at hoovering up those little suckers on the ocean floor.
Alrighty, quick question from Brendan. In comparison to last year, which sites surveyed this year have seen notable decreases or unexpected increases?
Yeah, let's see, Diana, I'm thinking through some of the sites you and I did this year, and that purple urchin recruitment event in Nellie's was
That's notable,
unsettling.
yeah.
Do you remember any other noticeable changes at Macklin or some of the Port Orford sites?
Nothing like what we saw at Nellie's Cove. Hundreds and hundreds and hundreds of tiny 1 centimeter urchins.
All of which Diana diligently counted. Like a real trooper. Jim, what about you at foul weather, and maybe if Aaron noticed anything at Arago area?
We've done some diving at foul weather this year. Still looks relatively balanced. We just completed 4 days on the south coast, from Humbug out to or all through the Marine Reserve and Island Rock in the comparison area. We did dive separately from the ODF&W Marine Reserve dives at Orford Reef, but we collected a bunch of data down there. So we still need to kind of compile that with ODF&W, but there was some it was spotty. You know, some spots were heavy urchins and some were not, but we'll have to kind of look at that data. We just finished it a week ago, so we'll have to look at that and kind of report back.
I can also chime in. Part of my answer is that I don't know, and that's important to share with you because you all need to know. I think everybody should know that we don't have a mandate to survey. There's no general money dedicated to surveying Oregon's kelp forests, and so what we got to do with this ORKA project, thanks to the U.S. taxpayer and the NOAA grant that we're reporting on now, is we got to do a serious effort to do surveys. But aside from the various little amounts of surveys that I do in my lab or Jim does out of the Oregon Coast Aquarium or Reef Check, thankfully we have Reef Check, but aside from that very small amount of work and the grand scheme of things, there isn't annual kelp forest survey work that's funded, believe it or not. The Oregon Department of Fish and Wildlife does a great job with what they can, but they don't have a dive program. They use volunteer divers to do the Marine Reserve surveys. So basically, part of it is that we don't really know how different it is in 2023 versus 2024. We did not do the level of effort that you saw from these data in 2023 in 2024. In reality, I was only able to do a few kelp forest surveys this year because we don't have the funding anymore. So it would be great to have the grassroots tell our elected officials, we want to fund surveys for kelp forests, not just for kelp, but these kinds of biological surveys are how we get answers and how we can answer whether things have changed. I can say that we were out today and diving and recording data on a kelp forest here at Cape Arago, and we only did a couple of surveys, so it's like I can't really say anything. We only have an N of 4 30-meter transects today, and we didn't see a lot of kelp in those couple of spots that we surveyed, even though we could see kelp on the surface nearby. So I hope that also kind of helps provide some context to why we don't have answers to that.
Alrighty, question from Lee. What is the plan for coaling? Is there significant funding for commercial divers to coal? What's the effort level for volunteer divers, as well as what's the update on coaling red urchins as well?
Hi, Lee. I'll chime in on this one. So the good news is that we do have, Sarah mentioned this, so we are working towards securing some additional funding from NOAA for another 2 years of work focused more on the now what question. With, taking into account what Aaron just said, they think that one thing to know, if you go and look at the report, you'll see a number of recommendations in the report, one of which is about having support for ongoing monitoring. Obviously, we have to be able to keep watching the effects of the things that we are doing. So that I concur with that. As far as where things are headed, there will be funding in the new grant. As Sarah mentioned, it covers urchin culling and removals, kelp enhancement, and sea star recovery support. On the urchin side, to your question, there will be both volunteer and commercial urchin culling and removals. Reef Check is going to be leading the culling effort, and the commercial divers will, they'll be doing commercial harvest work. To your question about red urchins, we're not there yet, but we are working actively with ODFW on some changes to the permitting regime that will allow the culling of both purple and red urchins where indicated. And we'll also be hiring a full-time person to coordinate all these urchin-related activities, because clearly it's a lot of work, as you know, and anyone who's participated in it knows. And as Aaron pointed out, it's really going to be a process of prioritization. Like, where can we focus this effort to the largest effect? And I'm really keen on this idea of sort of focusing on oases, places that we think we can do a decent job of protecting and restoring, so we maintain some of that kelp spore in the system, rather than seeing a widespread loss that we've seen in other places. So again, scale is a challenge. Scale is a challenge. Resources always. I think you asked sufficient. You used the term sufficient, and I would say that I would not say sufficient. I would say we're just getting started there. And to Aaron's point, I think we really need to make it clear to decision makers, funders, people who have the resources to make changes happen in our system, that we really need to make those changes, because we're up against a big challenge, and it's going to be ongoing, and we're going to be at it for a long time. And we need that level of commitment across the board, whether it's for surveys or it's for in-water work, or creating, doing workforce development in coastal communities with people who are invested and want to do this work, and create, actual earning opportunities for people in coastal communities who want to do this kind of work and other kinds of work that's similar to this. So I don't know if I hit all of the questions. I tried to. And Lee, we need to talk. Lots of things to unpack there.
I'd like to add to that, if that's okay, but I could also wait if anybody else wants to talk.
No, jump in.
Yeah, I mean, I like that question, Lee. Thank you. The one thing is that it's kind of framed like the volunteer dives have not been sufficient. Can the commercial dives be added? And I guess, you probably are fully aware of this, but to me, the thing is we can do as much commercial diving culling as we want, and it still won't be sufficient. Like, culling as a method is not going to be sufficient to recover kelp forests at the scale that we've lost kelp forests. It's just impossible. So it can happen, and it can happen that the culling can help these oases like Tom was talking about. And so just to be careful about, it's not going to be sufficient, and we understand that. And I think that that's one of the reasons why we're interested in doing more research, first and foremost, about what we can do with predator recovery. Because I'm not saying that Pycnopodia are the silver bullet that's going to fix everything, but out of all those levers we were talking about, if a natural predator recovers and if it consumes urchins at levels that we've measured in laboratory feeding trials, or even close to those levels, the natural abundance of that predator may not be the only factor that controls urchins. We get that, but it may have the most potential impact for helping our kelp forests recover naturally. So it might be the one lever that we should pull all the levers, but it might be the lever that we can pull that has where we actually win a lottery by pulling that lever. So that's why we're working on it. None of them are going to fix the problem, but some of them have a chance to make a significant dent. And I think that the possibility of Pycnopodia recovery, and even to an extent sea otter recovery, is really important levers that we should really be angling for.
Alrighty, I'll move on to the next question about predator reintroduction. So Nathan asked, sea stars are coming back, which is great for urchin culling efforts, but will sea star wasting disease come back as well? Could disease outbreak be a risk for future kelp restoration and urchin culling efforts? And I'm also going to throw in, people are mentioning sea otter reintroduction for redundancy, so I'm going to tack that on just so you can follow up on that.
Yeah, I'll kind of kick that off by saying that's one of the reasons that these community observations of where there are and how big they are and things like that is important to us, is because I tried to phrase it carefully in my presentation. This could be the beginning of sunflower sea stars coming back in Oregon. But Nathan's totally right that it could be that disease, affects 20% of the population every year, and it just really inhibits their ability to come back fully. So disease, there is some good ongoing research into what causes the disease. One of the huge questions out there is, can sea stars get resilience or resistance to sea star wasting disease? Is this new round of little babies that we see showing up, did they win the genetic lottery and they just happen to be resistant to the disease or something like that? So we don't know, and there's a lot of questions, and it's being able to keep track of where they are and how many of them there are and how big they are, tells us, helps us monitor whether this is, the real deal in terms of them coming back, or whether this is, how significant this could be. So it is, yeah, you're totally right. There's a lot of unknowns, but I think we gotta take this shot that we're being given. That's my thought. But yeah, Gravem, you're unmuted.
Oh yeah, there's definitely a risk of that. And but I do think that there is positive signs that populations in Washington and Alaska are holding on and starting to recover. There's still definitely disease flare-ups and populations that keep crashing, but it is no longer on the geographic scale that we originally saw the first outbreak in 10 years ago. And so even though there is certainly possibility that if we were to put thousands of pycnos in one spot next year, that they would get killed, but if we were to actually keep doing it or spread our eggs around, I do think that there's high possibility that they could make it. And then unlike us, they make millions of babies a year. So the potential for natural selection to play into this and promote the survival of the ones that are more hardy is pretty feasible. So it is definitely a risk, and it's but I think it's more of a monetary risk, and I don't think we can expect to succeed in any short time frame if we don't try.
Hey everyone, technical issues solved. I'm gonna get back into urchins as we talk about stars. Have we done any monitoring of the effectiveness of urchin culling? Given the density of purple urchins at some sites, can culling by divers actually make any headway? And given Aaron's comment that culling is not sufficient, how do you determine the level of investment that makes sense for it as an activity?
I can begin to speak to that. So globally, there's been papers that have come out looking at kelp forest restoration techniques. And one of the best papers that's come out on it found that when you do urchin culling well, it is actually one of the most successful kelp restoration techniques. It's the when you do it well, which Erin is totally right and has extensive experience with. The doing it well part is the hard part. So it can definitely be very effective. We were, we've been able to do some pilot scale stuff and urchin removal work and urchin culling work. We had a big effort back in 2021. This year, we were able, me and Diana and a few others were able to take about, I think it was 40,000, I think it was about 40,000 purple urchins total out of the Nelly's Cove area. And we went back a couple of weeks later and resurveyed, and we saw that there were still very few urchins. There was one transect where I counted one purple urchin in Nelly's Cove, which has never happened to me, and I've dove there dozens and dozens of times. Additionally, Carol did a experiment last year. If you cull in a little area, how quickly do the urchins come back? And Carol, correct me if I'm wrong, but I remember you finding that it wasn't particularly quick. It wasn't like over the course of like a week or 2 weeks or a month. It took longer for them to begin re-encroaching. So now I've gotten myself so far down the rabbit hole, I can't remember what the original question was, but that's all to say it can be successful. We have the money for the first time, really, the money and support and capacity to really hammer on the urchin culling and removal work next year. And you better believe we're going to be doing lots of follow-up surveys to figure out exactly how successful that was. So we're still in this, we don't know exactly. We're learning, we're taking the best techniques that we see working in other places. We're trying them here, keeping track of what happens, and we'll adjust as we go. But I feel confident that these urchin removals, we can do them well, and they can make a difference at some specific restoration sites. Like Erin said, not across the whole coast, but at specific places that people really care about.
How many of us are gardeners? I'm actually not, but I watch a lot of gardeners. I mean, when we garden and we take out the weeds, we don't think that we're gonna remove all the weeds from all of Earth, right? You're choosing to remove something from a patch that you care about, and then you benefit from that. And so that's what culling is. Culling is a targeted approach that makes a difference, if done well, in a spot. And that's meaningful for that spot. And it might have important meaning for beyond that spot. I think the science is still trying to understand how big the impact can be. But so you know what I mean? So that's part of why it's useful to do. You don't think you're going to remove all of the weeds in the world, but you still do it and it still matters.
Thanks, everyone. I don't see any more questions in the Q&A. Audience members, any last ones? Oh, we have one internally. Jim, please.
Yeah, I just wanted to touch on one thing, back to the sea star wasting and possible reemergence of it. There's always been some in my 30 years diving on the Oregon coast, occasionally you'll see some sea star wasting and on small scales, nothing like we saw in 2013, 2014. And it's kind of unknown whether that would happen again. We really don't know. But there's kind of a couple parts to that question, and one of them was otter reintroduction, and we didn't really touch on that. So I just wanted to encourage everyone to look at the ORKA Alliance website, read through the feasibility study. They keep it very updated. Beyond the feasibility study, there's also a great model there that you can go through. So that group that I'm also part of is making some progress. It's a long game. There's a lot of permitting to be had. There's a lot to do more with site selection. So I just wanted to encourage the folks that are still on the call to look deeper into that. We didn't really answer much on the otter question. So there's work being done there in parallel with this, and I think it's also important, and they very much tie together. That's all.
Do you see any more questions?
Yeah, I think Carl kind of got booted from some of the questions. A lot of these are more statistical based, which might carry a longer conversation. So some of you who asked some of these more stat specific questions, I would highly encourage you to reach out directly to Sara Hamilton. And I'm sure she'd love to talk stats with you. That's a shout out to Nathan, who's been asking these questions. But we do have a question, have there been attempts to correlate the large complex weather patterns like El Nino to observations in these changes?
I do think though that somebody in the panel can answer the anonymous question, attendee's question about, did we do a multivariate analysis? Why don't we talk about it?
We're doing that right now in a follow-up paper,
I
so
was
stay
just-
tuned. We didn't have the time to do it all in the status report. So like I said, this is just the beginning of a lot of research that needs to happen. So we just had a meeting yesterday where we talked specifically about doing a paper with a multivariate analysis. So excellent.
And it
point.
looks great. We did a version of it already and it looks awesome, but we decided that the average person doesn't get NMDS plots and we should do this report.
Lots more to come. And I can take a first stab at the El Nino and like climate oscillations question. There has been a lot of work done over decades on that question in California. And some of the things that hold true in California probably hold true here. One of the biggest things, I actually did a paper on this back in 2020 that I can share with folks if anybody wants it. But you know, like I said, we don't have a long history of kelp forest research here in Oregon, but all the signs point to El Nino matters a lot. You know, La Nina years, we tend to see La Nina years still tend to be cooler, wetter, a little bit less stormy, and bull kelp tends to do better here in Oregon during La Nina years. In general, all up and down the California current, El Nino years are tough on kelps because they're warm and they're stormy, and storms can rip out a lot of kelp from the substrate. So we've got some ideas around El Nino, but you know, some of the other climate oscillations, marine heat waves, long-term warming, there's a lot there. So again, that's another paper we should do sometime soon.
Sarah, I'm curious, you mentioned some of those warming patterns in El Nino, that it's warm and stormy. Does that get into that 0.2% of the time when kelp is thermally challenged? Is it during El Nino periods?
Yeah, I'm pretty sure when there have only been like 2 stretches of years where Port Orford has the temperature has gotten above 16 degrees, which is thought to be a pretty thermal threshold for bull kelp. And they were I think periods, and one was like the late 80s, early 90s, and the other one was 2014 through 2015 when we had those intense marine heat waves that happened. So yeah, that's definitely one of the indicators I kind of use as I'm going into a field season, is like, is this going to be a good year or a bad year? I go and check, is it a La Nina year or an El Nino year? And one of the things that the timing of those El Nino and La Nina can matter a lot. Like, is the El Nino happening during reproductive period? Or is it happening during the growth period? Because those reproductive phases can be really sensitive to warm temperatures and things like that.
I'd be happy to answer one of these anonymous attendee questions. So one says, if all levers are considered for kelp forest recovery, predator enhancement should include sea otter reintroduction. It's part of the longer term solution, providing predator redundancy, which could provide resilience for future against sea star wasting, essentially. So I agree with that point, but I want to make a really important point about that, which is that, and this ties into what Jim was talking about a minute ago. The sea otter reintroduction is a really long game. Like, it's like, in the big picture of things, with the science that's been done about, and you can learn about this if you you may already know, but I mean, if you look at the ORKA Alliance report, there's some, like Jim was talking about, there's some really interesting tools there for the average person to go into a web-based tool and play around with some modeling of what will happen based on what we know about sea otter biology. And essentially with sea otters, they reproduce so slowly, and there's only so many that will ever come back or be reestablished, that the sea otter impact to make a difference in Oregon's kelp forest is on the scale of many decades. Like if we were to introduce 100 sea otters next year to Oregon, I'm not saying that's what's going to happen, but if it's 100 or 200 animals within decades, it will still only be a few hundred to 1,000 or so animals, and they're not going to just spread like gangbusters all over the state, eating all urchins. So that's a very long-term prospect, and it's a very important lever to pull. I totally agree. It should be one of the predators that it rightfully belongs here. Human beings are the ones that took them out because of the fur trade, and they belong here, and we should probably put them back. But the thing is that it's not going to be a lever that has much impact in the short term.
Did we somehow answer all the questions? I know we didn't. I know we didn't answer all of my questions. Because I think there are so many more questions. You know, we just started to scratch the surface, I feel. Really good questions, though.
Yeah.
And I'm just gonna take the liberty of also, as seems like we're starting to wrap up, I just want to acknowledge Dr. Sara Hamilton for doing such a great job of presenting this status report. Thank you. And to all the panelists, fantastic job of fielding questions, easy questions, tough questions, kind of head scratcher questions. And this is one of the reasons I really like working with this group, because we do bring so many awesome perspectives and, you know, really push the ideas around and challenge paradigms and stuff and challenge each other sometimes. And I think that's really good. And I want to thank Carl and Caroline for moderating the Q&A. And for anybody out there who's still on the horn with us, just thanks for tuning in. As you probably heard a little bit during all this presentation and Q&A, you know, we're really just getting started. And you know, this is going to be a long game, as Aaron kind of talked about with regard to otters. But I think just generally, this is a problem that we're going to be living with for a long time. And I hope we can really develop the energy and the stamina, I'll say, and the resources to see it through, because it is going to take time. And I know that a lot of us are in it for the long haul, and hopefully, you know, if this is interesting to you, please tell your friends, tell your family, tell everybody you know that there's a lot of work to do and we need help. And we're going to keep needing to develop strategies, techniques, ways of understanding and doing work that will hopefully make the difference. And Aaron, I love the garden metaphor. It's really cool. And always love the idea of all the levers that we can push and pull and move around, because that's the only way we're going to find a path forward and to some kind of, you know, improvement scenario. So I just want to wrap it with that. If anybody has any final things to say or questions, I'm going to hand it back off to you guys. Seems like maybe that was it.
Yeah. Thanks so much, everybody, for everybody's
everyone.
time and energy and dedication. Nice work, folks.
Thanks for coming, everyone.
Thanks
Yeah.
for joining us
Yeah,
all.
thanks, everybody. Thanks for great questions.
All right.
Have a good evening.
Yep. Good night.
Bye.
Good night, everybody.
Bye.
I think if I leave, I'm gonna do this, stop recording.